delegates. This is AuditNet's Training Without Travel, part of the Training Without Travel series. And we're going to be looking today at auditing databases. You'll find that AuditNet is owned, and the president is Jim Kaplan, who has been providing webinars and internet-based audit support to auditors since before I was involved in auditing. He handles the AuditNet, and he also is the recipient of the IA's Bradford Cadmus Memorial Award, as well as the author of the Auditor's Guide to Internet Resources, the 2nd edition. Who am I? Well, I'm Richard Cascarino, and as I said, as punishment for your sins, you've got me for the next 2 hours. I'm a principal of Richard Cascarino and Associates, based in Colorado and also in Johannesburg in South Africa, and I'm broadcasting to you from South Africa at the moment. My background, I have some 30 years experience in IT audit, and training and consultancy in IT audit and internal audit, as well as IT security. I'm a past president of the Institute of Internal Auditors in South Africa, and I established the African region for the IIA Inc. I'm a member of ASACA, a member of the ACFE, and I'm the author of 3 books on auditing: Auditor's Guide to IT Auditing, which is in its 2nd edition, Internal Auditing and Integrated Approach, the 3rd edition is due out this week sometime, and Corporate Fraud and Internal Control, a Framework for Prevention. That's my background. As far as some housekeeping for this webinar is concerned, this webinar and its materials are the property of AuditNet. You've all received a copy of this, so I'm not going to go through it in detail. Sufficient to say that, in fact, I can hear Jim's come online, so I'll hand it back to him.
Thanks, Richard. I apologize for not being online, trying to multitask here. The webinar housekeeping, you received the slides this morning. I'm not going to go over the details. However, we are recording today's webinar, and you will receive a copy of the recording. We did send out the recordings for Tuesday's webinar, and those should be in your inbox, so you should have the link to that. We are operating under NASBA rules, so you will have to answer the polling questions, and if you answer all the polling questions and are in attendance for the entire time, you will receive your CPE certificates by email, and those will typically come out 2 to 5 days after the event is over. Also, you may submit questions via the chat box on your screen. I'll be moderating those questions. We'll either answer them during or at the conclusion of the webinar. Typically, we will answer them when we break for a polling question. After the webinar is over, you will have an opportunity to provide feedback through an evaluation form. Please complete that questionnaire and help us improve our webinars. The next slide provides information about the disclaimer. You should have received that as well. And the disclaimer information, I'm not going to read that to you in order that we can provide the maximum amount of time for Richard. So at this point, let me turn it back to Richard for auditing database structures. Richard?
Thanks, Jim. And welcome to those of you who are returning, and welcome to those who are new, starting with this webinar. What we're going to be covering today is database management systems. And the reason that we're doing that is because a tremendous amount of the interrogation that IT auditors do is based around application systems and the databases supporting those application systems. So we have out in the great wide world the users. They're communicating via system software coming into our network, coming in through the operating system, through transaction processing monitors, getting down to the application systems themselves, and the application systems are extracting information from databases and writing out the databases. Now, we covered very briefly some of this on Tuesday's webinar. Today we'll be going into a lot more detail because it's a critical area for the auditors. It's where the audit evidence resides when we are doing audit tests. So we need to understand how it's structured and how we can gain access to it, how we can interrogate it, and what that will mean when we interrogate it. So we'll take a look at the jargon, we'll look at the different types of DBMS, because all of them work in slightly different ways. We'll have a look at the role of the DBA looking after the database and some of the tools that the DBA uses to maintain the database can be very effective audit tools. They're not designed for auditors, they're not intended to be audit tools, but they are doing the kind of thing that auditors want to do. We'll also take a look at restart and recovery, which is a critical area for databases. Because we are sharing data among a plethora of users, we need to be able to get that database up quickly if something goes wrong. It's too late to turn around and say, oh, the database system has crashed. We'll need to go to last night's backup, restore from that. That should take us about 4 hours. Then we'll need to reprocess all of the transactions. That will take us about another 6 hours. So we should be up and running in 11 hours. If something goes wrong at database level, it's got to go down and come back up itself, preferably without human intervention, and preferably in such a form that the user sees, oh look, my system's going slow. Oh no, it's not going slow, after all it's back. It should literally be a couple of seconds at most for recovery. But that takes a lot of planning and it takes a lot of software, and from an ongoing business continuity perspective, auditors need to be sure that that is actually going to work. We can also review the database design to ensure that it is appropriate, that the right people have access to the right functionality. We'll have a look at the impact of the database on our audit methodologies, and we'll take a look at actually auditing the database. How do you go about it? Where do you start? Now obviously, if you're going to audit that kind of system, you're going to need to use computer-assisted audit tools and techniques. So we'll take a look at CATs in the database environment, what kind of CATs there are, when you would use them, what you would use them for, and what you're trying to prove. Okay, so let's kick off. Databases. For those of you who are here on Tuesday, bear with me. What is a database? A database is a collection of data logically organized to meet the information requirements of a universe of users. We can have multiple users accessing the same database. Now let's just take one example and stick with that one example, and let's talk in terms of a human resources database. I could have a manager who is authorized to see everything in that database, but I could have a clerk who's entitled to add people into that database but not delete them. I could have a person who's entitled to look at the salary but not change it, and another user who's not even entitled to look at the salary. So we've got a universe of different users out of there, and they all have different requirements in terms of access to the data. And that's simply taking one business process, human resources. If we're moving out into the data warehouse, which is trying to service all functionality within the organization, you have a massive requirement for different users seeing different things and being able to do different things. Now, in the olden days, that had to be built into the programs. So depending on your user ID, you would go to one part of the program which would give you some functionality. A different user ID would go to a different function in the program. With a database, I can have a schema which describes everything that's in the database and a sub-schema which describes the bits that you can have. And if I put that in one place, in my data dictionary, then any user using the same programs can come in, and their access and their abilities are restricted centrally at the database. So I don't need to build it into every single program, and I don't need to worry about a programmer writing a program with different access rights. They're going to come in through our data dictionary, and they're all going to see as the designer intended it to be. So how do we do that? Well, we do it using software. Generally, database management systems are software driven. The exception being, I apologize, that was me touching my mouse. The exception being the IBM I-Series, which used to be the AS400. It's a unique system in as much as the database management system is actually hardwired into the machine. So it's not a software add-on. Now there's a disadvantage. It means that if you're running an I-Series, you're running the I-Series database management system. You cannot run any other one on an I-Series. If I'm running a different type of machine, I could decide I want to run Oracle, or I want to run Datacom DB, or I want to run IDMS, or IMS, or DB2, depending on my needs and on the architecture that we've set up. On the I-Series, you can't. You get it built in. Now the advantage is it's very, very fast because it's hardwired. It's very, very powerful. And it works in the same way as some of the best databases out there. So don't feel that you're disadvantaged because if your company is running an I-Series, that's the only system you can use. It's a very powerful database management system. But all of them work the same way. They provide the organization of the database, how you will get into it, what it looks like, how it's structured. It provides access and control functions. It handles backups. It handles recovery based on the specifications from our database administrator. It handles access control. The user still has to decide who gains access to what and what are they allowed to do when they get there. But all of those controls get built in through the DBMS. And the place it resides is within our data dictionary directory system. Again, a software part of the database management system which manages that repository of information about the data and the database environment. So that's where we define that in the days of Y2K, the year was 2 digits. We've now gone to a 4-digit year. We define that in the data dictionary. There was a lot of fuss made about Y2K when it came in. For many organizations who were already running databases, it was a piece of cake to migrate to Y2K. If you were not running a database management system, and we had a lot of legacy systems which were not database based, then what you had to do was take every single program that had been written with the definition of the data in it and change it from 2 digits to 4 digits. Recompile the program, relink edit the program, convert the data files, retest everything in sight before you could go live in Y2K. If you had a database system, the way you approached it was you took the data and stripped it, and the database administrator had utilities to do that, stripped it off of the database, you redefined that data field from 2 digits to 4 digits, and you reloaded the database. That was it, done. No programs to recompile, no extra testing to be done, conversion done. Now everyone tested it to make sure it would work anyway, but that was the principle behind it. And that's the advantage that you get when you separate the data definitions from the programs. DBA is the guy who makes all of this happen. He coordinates and controls all of the data-related activities, everything except entering data and taking the data out. The DBA really doesn't care what the name of the person on the payroll is. All the DBA cares about is that the name is 20 digits long, it's on that data set, and you access it in this way. User system interfaces. Because we want to separate and have data independence, separate the definitions of the data from the actual application programs, we need a component within our database environment which will simply be called by an application program, and it will say, get me that piece of information, add this to the database, take that off the database, move this from here to there, and it transforms the data into the information which will then be supplied to the application program for the end user. Data structures we talked about on Tuesday, and we'll talk a bit more about them today, handle the interrelationship of data. So I can have a customer with multiple orders. I cannot have an order without a customer. So here I have a one customer to many orders, but I cannot have, and I can have a one customer without any orders, but I cannot have an order without any customers. So I can specify that interrelationship of data as part of our validation procedures. The storage structures are the methods and techniques that the DBMS is going to use to physically represent what that data looks like out on our storage devices. How they are linked together, if they are linked together, when linkage takes place. And then also built in the access methods, the software logic procedures used to retrieve, insert, modify and delete, and that's part of the database management system, not part of the application program. So we have a central place where we can exercise control. Or from an audit perspective, we have a central place where control can break down if it's not been designed and implemented properly. What that means is we can now have data independence. We can cope with multiple users with different logical views. We can add new users with new logical views. We can change the logical views. We can change the physical representation from a 2-digit date to a 4-digit date. If we want to share data, that's what we're trying to achieve. The how we do it is by making data independent of the application systems. If we look at how this works within our principles of data structures are how we model business functionality in terms of information. So if you're designing a new computer system, an application system, I'm going to go to the business and say, how does information flow within this part of the business? What pieces of information have to be linked together for this thing to work? And there are different structures depending on the nature of the business. Information is structured differently, and depending on the structure will depend the database management system that I'm going to go and buy. Now, I mentioned to you that if you buy an AS400, an I-series, you are stuck with what it comes with. What it comes with is the relational model, which is the latest and the most powerful model for databases. Not necessarily the fastest, but very powerful. The lack of speed with relational databases, I'll rephrase that, with some relational databases, is offset in the I-series by the fact that it's hardwired, not software driven. And that is the basis that we then use for designing what our functional database looks like. If we look at the conceptual structure of data, okay, how data actually works. All of the DBMSs that are out there that you can buy vary largely in how data is accessed and manipulated. So if we look at the entry access methods, we have, for example, I can go and say, give me a customer. Now, read the first order that they have. Or I can say, jump into the middle of that disk and get me that customer. Or I can say, here is the data in the order that we threw it in. Not in customer number order, not in date order, just the way it was thrown in. And we can then index it by customers, by dates, by colors, by whatever. We can also navigate through the database. So if I've accessed the customer number 21, randomly, go and get me customer number 21 off the disk. Now, read the first order for that customer. Then read the next order, then read the next order, then read the next order. There may be 300,000 orders out there, but it will get me the first one for that customer. Then it will jump straight to the next one for that customer. It doesn't have to read every single order to find the ones I'm looking for. It will read the next, read the next, read the next. And I can also go into the customer and say, read the last. Now read the previous, read the previous, read the previous. So I can navigate the database forwards or backwards. And the way we do that typically is using embedded links. There is one oddball database management system that doesn't use any of these, and that's ADABAS. ADABAS, again, a tremendously flexible database. But unlike every other database where the data is put onto either files or onto tables, if you're dealing with a relational database, and these files, the records within these are linked together, ADABAS works on something called an inverted index. And what happens there is it's one big file. So the first record in the file might be your payroll record. The next is an order for a customer. The next is anything you choose, a bank deposit record. And they're all mixed up. Now, the nice advantage of that from a confidentiality perspective is if you print out that big file, you've no idea what starts where and where it finishes and what the next one is and what this means and what that means. It's just a jumble of data all mixed up. And to access it, you've got to go in through the ADABAS indexes in order to read the files in a meaningful manner. The data dictionary directory system, the data dictionary tells us what is in a database or a database file. And that's the logical view, the name of the field, the description, any synonyms. That's all in the data dictionary. That's your yellow pages. Data directory tells you where that data is, which file it's on, which disk it's on, and how do you access it. To get to that order, I've got to go through a customer to get there. To get to a customer, I can go directly to a customer based on the customer number. So the data directory tells physically what does that look like, what disk it's on, what track it's on, what cylinder it's on, the address, the physical representation, to make sure I get to the right piece of information. So when we're writing, or when the DBA is putting entities into that data dictionary and directory system, he needs to tell it the identification, the source, the classification of the data, the usage of the data, any qualifications of the data, and the relationships between this and that. Is it one to many? Is it many to many? Is it standalone? What does this look like in terms of relationships? As far as the DDDS, even if you don't have a database management system, It's a useful tool independent of that need. But it's a problem from an audit perspective. If you have a data dictionary directory system, you're faced with the same problem as if you had no database management system at all. Anything you look at, anything you read is narrative. Documentation is a description. It may not be accurate. It may be out of date. It may be 5 years ago. It may be as it was when we wrote the system. And that's the problem if you're using a data dictionary system independently of a DBMS. It's there, it looks like a DBMS one, but can you trust it? It's how we can still coordinate shared data usage, and we can still have control over modification of programs and files. But it really became popular with the advent of DBMSs, where we had the opportunity to share data, but now we have to control the sharing of that data. Who's got access to what, on what basis, and it's become critical with privacy legislation coming. We have incredibly complex relationships on our databases these days, so our data dictionary system handles that for us. And you'll find that the databases that you're dealing with will have what's called an active data dictionary. You can have an active data dictionary or a passive data dictionary. The one that's at the top of the screen, independent of the DBMS, is a passive data dictionary. It's narrative, it's there. If anybody remembers to keep it up to date, it could be helpful. If it's out of date, it's worse than useless. If you're dealing with a database with an active data dictionary, you cannot, from a program, access the data without going through the data dictionary. It's the only place that knows what it looks like. It's the only place that knows what it's called. It's the only place that tells you how to access it, which means from an audit perspective, that data dictionary is 100% accurate and 100% up to date. So as a source of information for the auditor about what's going on inside the application system, it's beautiful and it's up to date. Now, the activity is a function of the number of components dependent on the data dictionary directory system for metadata. Okay, what's metadata? Metadata is data about the actual data. Okay, so that's where, when we define what it looks like and where it is and how to get to it and which application programs can access it, etc., that's metadata. And when I talked about an active data dictionary, there are different kinds of active data dictionary. And the degree of activity is a function of the time that the component is bound to its metadata. So in other words, if I write the program and I have to bind that program to the metadata before we even compile it, that's one level. When it's compiling, it can be bound at that time. When it's run, it can be bound at that time. Or when the whole thing is actually executed, it can be bound at that time. And the degree of activity, the more active the data dictionary is, the more you can trust it, the more you can rely on it. But the more overhead there is on the machine for keeping it up to date. And we use embedded links for implementing relationships between records on our database. And that brings us to our first polling question. And our first polling question, I will launch. And you can see the first polling question. The software that manages a repository of information about data in the database environment is the DBMS, the data dictionary, the storage structures, user system interfaces. So which bit of software manages that repository of information? Once again, you don't have to get the answer right, but you do have to vote if you want your CPE. We're up to 95% complete. I'll give it another couple of seconds. Again, if you're operating from a tablet, you will not be able to answer the questions interactively. Take a note of what your answer is, put them all together in one email and send them through to Jim. Okay. I'll close the poll and share the results. And the majority of people have said the DBMS. And it's in the reading of the question. The DBMS handles the whole thing, but the software that manages that repository of information is the data dictionary. That's the information about the database and the database environment. Okay. So let's take a look at the different types of database that there are. So the first type of database is the hierarchical database. Sorry, it's a sequential database, and that's a sequential, same as sequential files, where you pre-database you had the payroll file with the payroll number, the name, the department code, the salary, leave, etc., all in one record. And then the next record was literally the next record in sequence. And there were limitations, there were severe limitations in that. And we moved to the hierarchical approach, then we moved to network, then to relational models, all of them having the same components. The data definition language, now in sequential databases, that was built into the program. The storage structure definition language was built into the program. In a COBOL program, you would have a field number, picture, 7 digits, alphanumeric, 2 decimal places, and it was all defined within the program. Data manipulation language, it was all done within the program. Nowadays, there will be separate components for each of those, all part of the DBMS itself. And the DBMS comes with standard procedures and utilities that allows the DBA to do whatever is required to that database, reorganize it, sort it, when something goes wrong, recover it, etc. So the sequential approach worked on the fundamental assumption that was a direct relationship between data. Here is the record, there is the employee number, the employee name is related to the number is related to the employee name, and that was it. And there really wasn't a lot you could do other than say, go read the record. Okay, which resulted in some programs being written where the database was one record. I looked at one payroll for a government department, and the record length was 5,000 characters, because when you joined the government department, they added you to the payroll. On your first pay, that was added to your record. The second pay, that was added to your record. The third pay, that was added to your record. So there was one whole record with every single thing about you. If you were promoted, if you got married, if you got divorced, that was on that single record, which was a nightmare. It's like having a filing cabinet. If you walk into personnel, human resources, you'll find, or you used to find, filing cabinets galore. And if I wanted to find out anything about you, I opened the drawer, pulled out your file, and everything about you is in that file. But if I want to know how many left-handed, red-headed plumbers were in our apprenticeship scheme in 2012, there's no way of getting it. I have to pull out every single file and go through it to see if this is a person is left-handed, if they're red-headed, if they're a plumber, if they were an apprentice, were they in the scheme at that time? And I'm going to have to do that for every single drawer in the filing cabinet. And that's the problem with the sequential approach. Now, that's not how business maps itself. If we look at how a business process maps itself, typically it's a hierarchy. So in the organization, there is human resources, and in human resources we'll have payroll, pensions, we'll have leave, etc. Within payroll, we'll have management, etc. And this is the hierarchy. So the original concept for database management systems was, let's have a hierarchy, because that's what business looks like. And that's the hierarchical database structure that you can see in front of you now. We've got our employee number with employee name, payroll, employee pay, employee deductions, pay details, etc. And everything is linked together through that employee number. But if I want to look at one employee and look at their pay for January and February, I'm going to have to go to the employee number, come down, go across to where it says pay, go down, go across to where it says January. Great. Now I want to see the deductions for January as well. So I'm going to have to go back up to pay, back up to the employee number, across to the deductions, come down, go to the deductions for January. So I'm going up and down those chains like a yo-yo. Okay, and that was the problem with the hierarchical approach. You'll still find hierarchical databases out there. IBM's IMS is a hierarchical database. Why are we still using them? Because they are fast. You go up and down those chains at lightning speed. You cannot go across. If you want to go across, you've got to go up, down, up, across, down, up, across, down, up, across, down. So you don't want to manipulate and maneuver within the database. But as long as you're simply processing one type of transaction, they are very, very fast. Very common in banking. Okay. Terminology, you'll come across root segments. This is just jargon that you'll come across when you're speaking to IT in a hierarchical environment. They'll talk about the root segment, which is, for example, the employee number. The parent segment would be the employee pay, with children, pay for January, pay for February. And from the employee number, you can have twins. So we've got the employee pay and employee deductions with pay details January and deductions for January. But that isn't very good if you're trying to go across. Now, many years ago, funnily enough, a ball bearing manufacturer had an IT division that said, this is ridiculous. We need to be able to maneuver within the database. And they came up with the concept of the network approach to database management, where the fundamental assumption was that there's some general relationship between data. But that relationship can be whatever I define. So you can see on there, you've got the same structure, but the pay details of January are linked to February. So when I come down through my employee number to employee pay to pay details January, I don't need to go back up the chain. I can jump straight across to pay details February. And if I choose, I could link pay details January to deductions January and pay details February to deductions February. So I can define any structure I choose. And the records themselves can handle multiple fields. Problem: the more structures I define, the more the machine has to keep the linkages up to date. So if you have a complex structure, it puts a tremendous overhead on the machine to keep all of these chains and pointers up to date. I have a question coming in. Are trees in PeopleSoft an example of a hierarchical structure? Not exactly. What you're getting with PeopleSoft, as far as I'm aware, you're getting a network type approach. If you look at this particular network, you'll see within the network there is a structure. Okay, you don't have to use all of the chains and pointers. You can define it if you have a network type database, a codicil database, as they're known, then you can define it as a network. And when you want to expand, then you can add in chains and pointers to go across the database. Okay. As I said, this was developed by an IT division within a ball bearing manufacturer. The head of IT went to the company director and said, "We should sell this." And the board chairman said, "I hate to tell you, but we make ball bearings. We don't sell software." So the IS manager said, "Well, look, would you let me sell it?" So he said, "Yes, well, you can sell it, you can have it, you developed it. We're not interested." So he sold it, and he sold it to one company, and it became called IDMS. He sold it to Sperry, and it became System 2000. He sold it to Unisys, and it became DMS2. So all of the codicil databases came from that original common source. And that was fine in as far as it went, but the overhead on the machines started getting problematic. Not only that, if I now want to link January pay details to January deductions, it's not simply a question of defining a linkage. I have to take the data, unload it, define the linkage, reload it, and let the DBMS rebuild all of these chains and pointers. So it can be problematic. So we went back to an original concept. When I first started work in IT many years ago, they came up with the concept of the corporate database. And the corporate database said, now that we've got a computer, let's just throw data into it. Don't worry about it. We'll figure out how to get to it when we need it. Unfortunately, without the appropriate software tools to do that, and we didn't have them in those days, all you ended up with was a big filing cabinet with lots of files in it in random order, and nobody knows where anything is. So that didn't work. But when networks started being a problem, they came up with the concept of the relational model. And the relational model went back to that original idea of take the data, put it in there, and we'll define the relationships when we need to use it. But it's not a question of just throwing data in. We need to make sure that there will be some form of mathematical relationship between the data. Now, a term that you might come across in database management systems within IT is data normalization. And the concept with data normalization said, instead of having the employee number in 5 files, let's put it in 1 file in the database and everyone can address it. Relational models, to a certain extent, obviate that. We go back to having duplicate information held on our database. But duplicate deliberately held so that we can have definitions of mathematical relationships. And you can see there we've got an employee table, we've got a department table. The employee table has got 3 fields, the employee number, the department number, and the name. The department table has got 2 fields, the department number and the department name. But because we have a common field, department number, I can specify a mathematical relationship, which is normally equality, but sometimes not equal. Show me all of the employees who do not have a presence, who have got a department code which doesn't exist on the department table. In other words, these are employees who are going through the payroll, perhaps, for a department that doesn't exist. Now, when the auditors come to audit, they go from department to department to department. If there's someone in the department that doesn't exist, it's a strong chance they'll never find it. So, what can we do if we've got that kind of relationship? Well, I can go in and I can say select. Select all employees. I can update. I can insert. And I can delete. And you'll see it says insert creates a new tuple. What is a tuple? A tuple is a table entry. If you're going to create something brand new and call it a relational database, you cannot use the same jargon that everybody else uses. You've got to invent your own jargon. So in relational databases, we do not have files, we have tables. And we don't have records, we have table entries or tuples, which funnily enough look like a record sitting in what looks like a file. Or put it another way, it looks like an Excel spreadsheet. And a tuple looks like a row in an Excel spreadsheet. So I can insert a tuple or delete a tuple. But I don't just have to do it with one file or one table. I can qualify it. I can say, pick up that record from that table where the following conditions exist. So pick up employees from the employee table where department code equals, what did we say? 47 or 43? Well, we're looking at the auditors. So give me all of the people from employee table where department number equals 43 and where date of birth is greater than this or whatever. So I can have multiple conditions with using an and to join them or using an or to get disjunction of those conditions. Now what does that mean in reality? Well, in reality, I can say select employee equals name from employee equals database where department equals B3 and position equals manager. And that's going to give me the managers in department BO3, AB Jones and CD Smith. And what it actually gives you is it builds a table, a temporary table in memory. The result of a relational database manipulation is always another table. And the table is used and then thrown away. Okay, and that's a critical one for you to realize that this is a temporary thing. Now, if I'm going to keep doing that over and over and over again, then I'm going to be building tables, throwing them away, building tables, throwing them away, building tables, throwing them away. So in actual fact, the DBMS doesn't throw them away. It builds the table and holds it in memory. And when you interrogate, you're not interrogating the disk anymore, you're interrogating memory. When you update, you're not updating the disk, you're updating memory. And periodically, the database management system will say, I have reached a quiet point, take everything that's in memory and commit it to disk. So now I've got it permanently on disk. But if anything goes wrong in the interim, if we lose power in the interim, everything that's in memory is lost. So I need to commit it to disk frequently enough to secure my data, but infrequently enough to give me efficiency in the processing. The more often I write to disk, the longer it's going to take. So we have our database. I mentioned to you the inverted file structure and the inverted list. This is the ADABAS of this world, where we have indexes and pointers. And you can see there we've got a file with number 1 Ford blue, number 2 BMW blue, number 3 Ford red, number 4 Ford blue. And I can build an index that says Fords are 1, 3 and 4, BMW is 2, it's indexed by manufacturer. Indexed by color is 1, 2 and 4, indexed for blue, red is number 3. And I can then access via the indexes. Now I said there's a plethora of packages out there. Just to give you some idea, we've got ADABAS by Software AG. Very popular, very powerful, very unique. Okay, there's no such thing as very unique. It's unique or it's not unique, but it's unique. IDMS from the Cullinan Corporation, now Computer Associates. IMS from IBM is a hierarchical database. DB2 is a relational database. And a lot of organizations use IMS for the number crunching, if you've got high volume number crunching to do, and then port it across to DB2 for interrogations, if you've got flexible interrogations that you need to do. System 2000s came originally from Mir System Corporation. Total came from Syncom Systems. DMS2 from Unisys. Datacom from ADR, etc. And those typically will form the basis for the application systems that we will then buy. And that brings us to our next polling question. Next polling question is looking at database structures. So I'll launch the polling question for you. And you can see there database structure where there's a fundamental mathematical relationship among data as an example of sequential, hierarchical, network, or relational. Please vote now. We're up to 90%. I'll leave it for another 10 seconds or so. And we'll close the polling and share the results. And you can see the bulk of people went for relational database. That's the one where it's either equal or it's not equal. There's a mathematical relationship among the data. Okay. Moving on. Who looks after my database management system? Well, basically it's the DBA. And we know that the DBA is there to coordinate the information content of the database. He doesn't care what the data itself says. What he cares is what the data looks like, how it's structured, how you access it. He doesn't care who can access it, but he does care what the access rules are, because he sets them up under the direction of the user. The user will tell them, I want staff to be able to do these things. I'm not telling you who they are, but I want staff to be able to do these things. He will set up the sub-schemas to allow people to access in these ways. And then it's up to the user to decide who is the person who's going to be able to do that. He also decides the storage structure and the access strategies for efficiency of DBMS operations. He has to liaise with the users. He will define authorization checks and validation procedures to meet the requirements of the users. He also defines a strategy for backup and recovery. How often do we back up? How do we back up? And he will monitor performance and respond to any changes in requirements. So if there's an access path that is never used, there's an overhead on the machine that's unnecessary, he will get rid of that access path for efficiency purposes. Tools of a DBA. He has a standard set of programs that comes with the database management system, and they handle loading data into it, unloading data from it, reorganizing the data to clean up any gaps or spaces on the disk, to do statistical analysis to show which users are using which access paths from where to gain access to what. Now, it's not eavesdropping on the user, it's to try and find more efficient ways to facilitate the users getting in there. But from an audit perspective, That's a very interesting analysis to find out who's accessing what, from where, how. They also handle the journals. What is a journal? A journal is a log file. And there are two major journals that we'll take a look at, the before journal and the after journal. And they are used primarily in recovery if something goes wrong. Recovery, we'll use a data dictionary and we'll use a database analyzer to analyze what went wrong so that we can fix it. Okay. I did see one internal audit department who were concerned that the database administrator had powerful tools that would allow them to go in and manipulate live data, which is what they can do if something goes wrong. Now, they're supposed to do it with the authority of the user, under the supervision of the user, and the user is supposed to verify that when they fix things, they were fixed properly to their user's requirements. Now, if the user is not IT literate, they may ask audit to do it for them, or they may call on a consultant to do it for them. But nevertheless, it has to be done. In this particular organization, audit were terribly concerned that DBAs had these tools. So they wrote a report and said, we are very upset about this because there could be a risk here. Management sent a reply that said, we agree. In future, all direct repairs on the database will be done by internal audit. Ouch. You've just taken the monkey off of their back and put it on your back. However, because they are required to be able to repair it in the event of a catastrophic disaster, we will not remove the ability from the DBA, but if anything goes wrong now, we'll blame the auditors. So be careful when you say, oh, that's a nasty tool. Yes, it is, but somebody has to be able to do it. They use it for recovery. When do we have to recover? Well, it could be when something goes wrong. You try to insert a record that's already there. You try to replace a record that's not there. You try to update a payroll record for someone who we don't employ. When a DB operation fails, when you say get next and it says, I can't find out who's next. My chain or pointer has been broken. I had an argument with one DBA on an IDMS site where he said that cannot happen. The DBMS makes sure that all chains and pointers have full integrity. And I was able to say to him, well, if you go to your own utilities manual and you look on page 35, you'll see that you have a utility that allows you to walk the database looking for broken chains so that you can fix them. If it's not possible, they would not give you a utility to do that. It's not desirable, but in any computer system, anything is possible, not necessarily logically desirable. We get transaction failure. We talked about that on Tuesday, deadlock, where two transactions are trying to access two records at the same time. One locks one locks the other, and neither will release it. The DBMS has to figure out how to get that back. You can have system failure where the power goes down and everything that's in memory is lost. Remember I said everything that's in memory, we do things in memory, we don't write it to disk because that's an overhead. The one thing that you do write to disk immediately are your log files. You do not buffer the log files. They get committed to disk immediately, which means if the system crashes and you've lost what's in memory, then all they have to do is bring up the database as at the last quiet point when everything had been updated, and then just roll the log files forward to bring it back, and that can take a second and a half. If you've got a media failure, you've got a head crash, for example, and your whole disk has gone haywire, then you're going to have to go back to last night's backup, restore, and then use your log files to roll forward from last night's quiet point, which means you do not ever put your log files on the same disk drive as your live data. Because if you lose that, you've lost your live data and you've lost your log files. So you've got no way of going back and recovering. What are we trying to do when we recover? We're trying to reinstate our database to a known state, okay, to a point at which we knew everything was okay. We want to minimize lost work. We want to get it to the stage where if you've pressed a button and that crashed it, that one transaction has been lost, the one that crashed the system, but not everything else. We want to allow recovery on a transaction-by-transaction basis, and we want it to be fast, with a minimal manual work, while ensuring that the recovery data itself is kept safe. And we've got to be able to cover for all of those different types of failure, for hardware failure, for logic failure, for errors, for loss of power, whatever it happens to be. So how do we recover? Well, on a database, you can roll back. If something has gone wrong, some transaction has crashed the database, then you can process backwards, roll backwards until you get to where you were okay, your last checkpoint, and then roll forward from there. When I started in computers, many years ago, I worked for the Department of National Savings in the UK. We were just computerizing, and we had moved 500,000 accounts onto the computer using punch cards. When I joined them, because I was a genius, they put me in charge of the most important program, the main daily update. Actually, that's rubbish. Because I was a trainee and brand new, they gave me a system that was working and said, you are now in charge of the main daily update. Do not ever touch anything, or we will hang, draw, and quarter you. If something goes wrong, call the boss. Fine, I'm in charge of the main daily update. I'm important. In the fullness of time, I got a phone call at 3 o'clock in the morning in the middle of winter. I had to make my way down 5 flights of stairs to get to the phone at that time, in the freezing cold. And a guy from Glasgow said to me, the main daily update is just locked out. What should we do? Repeat after me, our Father. I did the only thing I could do. I said, listen, leave it with me. I'll get my boss to phone you back. And I phoned my boss and said, the main daily update is locked out. It's all yours. And what had happened was 17 transactions had come in a specific order that unset a switch that should have been set. And the computer said, I don't know what to do. Stop. And at that time, there was no database, so it took us 2 days to get that thing back up and running. Okay. Now, it needs to be able to roll back, roll forward, and do it itself without any human intervention and recover everything. Except if you have a media failure where you're going to have some human intervention to load up the correct backup copy and recover everything. We can also have compensating transactions on our journal entries, and the DBA will have what are known as salvation routines, which will get you back when all else fails. So, what do we need in order to recover if something goes wrong? Well, we need a before image. Before image says, before this transaction takes place, and before any damage is done, I want a copy as at that point in time. So that if something goes wrong, I can say, okay, forget that update, let's go back to what it looked like before. So before this transaction, we had 5 in stock. This transaction said -3. That should give us 2 in stock. It crashed. Okay, let's go back to the 5 that we had and move on from there. After the database is updated, I need an after image so that if I need to, I can redo that change. Now, why not simply record all of the transactions and redo them all? Well, we may have 100,000 transactions, but those 100,000 transactions 50,000 of them may be accessing one record, our stock on hand. So I don't need to keep all 50,000 transactions accessing that particular record. All I need is the before record and the after, and I can dump all of the transactions in between. Now, from an audit perspective, what does that mean? It means that you don't have a contiguous audit trail. You have before a transaction and after a transaction. But periodically, as these logs are being recorded, they will say, here is a checkpoint, there is another checkpoint. I don't need all of those before and after images between those two checkpoints. Squash them out. Give me the one when that checkpoint was first created, and give me the last one when the checkpoint was created again. And I don't need all the garbage in between. So from an audit perspective, I cannot necessarily see all of the transactions in between. But if it's all you've got, then it's important that you know what you've got on there. Program IDs, transaction IDs, etc. Looking at it from that perspective, we need those checkpoints and save points. Checkpoint or a save point, depending on whose software you're using and therefore what jargon you're using, is used to define a stable state of the database for recovery. Okay, so at this point, nothing's happening. Okay, freeze everything, flush everything, commit it all to disk, mark it. All we have to do is go back to that. So the database gets reinstated to the last checkpoint, and then the log is processed forward and the system gets reinstated. So we've got our backup images, we've got our journals and logs, we've got our save points, we've got system checkpoints, and we've got our transactions files kept in separate files. You don't have to use before and after image logs. Some organizations do, some organizations don't. Some organizations will turn around and say, we have sufficient funds because it's not a cheap exercise. We will mirror everything. Every time that transaction happens there, it will also happen over there. And if that whole system crashes, we flip over to the mirror system. So I don't need before and after image logs. We will flip over and then we can recover the other one at leisure, depending on what went wrong. Tools of recovery and restart for the DBA include the recovery log, the checkpoint itself, last night's database dump, and the database restart and recovery software. As I said, the recovery log, the before and after. Before has the data before modification, the date and time of the change, the processing program that modified that, and that would be written immediately to the log stored on some kind of direct access file. And we use that at a point of failure to back out faulty transactions. So when that one crashes, we go before, till we get back to the latest checkpoint. And at that point, we know everything was okay. We can then use our after image log to roll forward. And roll it forward to the restored database dump or to our checkpoint to take it back to the point of failure. At that point, it went wrong. So stop immediately before that. Now carry on. Okay. Taking at a quiet point in the database where all update activity is terminated, and what it does, what the DBMS will do, is it will say anything that's coming in while I'm marking this checkpoint, while I'm flushing my buffers, stop it, hold it. Just keep those in memory until I've committed all of this lot, now carry on. And again, that can take half a second. Checkpoints can be taken at any time. It depends on what the DBA has told the DBMS to do, or what the application programmer has told their application program to do. You may find that you have a critical transaction. The programmer may program into his application system any transaction coming in that's worth over $1 million. Don't mess around. Commit to disk. It's called an explicit commit, and mark it as a checkpoint. Flush the buffers, get it out, mark this. We don't want to lose this one. Or it can be based on elapsed time, or it can be based on number of transactions processed, whatever is appropriate for that organization. And that brings us to our third polling question. Polling question number 3 relates to recovery. And it says rolling a database back to the last safe point would involve the use of before image logs, after image logs, both before and after image, neither before nor after images. Rolling it back to the last safe point. Remember what you're doing. Something has crashed. I need to go back to when it was okay. That was the last checkpoint. So I'm going to have to roll back using another 10 seconds. We'll close and share. If we're rolling backwards, we're using the before image. Before things went wrong, let's go back, let's go back, let's go back. Okay, at this point everything was okay. Now, if I was doing recovery, let's go forward, let's go forward, let's go forward using the after image. Okay, so in recovery, we'd use both the before and after, but simply to roll it back, you would use the before image. Okay. What about the data dictionary? I said the data dictionary is the yellow pages of the database. Okay. The factors or the functions of a data dictionary is the repository for what the data looks like, where it is, definition, structures, relationships, usage, etc. of all system objects, not just files, but programs, images of files, access routes, all of that, all held in the data dictionary. You, as the auditor, could be asked to do a review of the database design. Okay. Is this a well-designed database? And you sit there and think, how the hell do I know if it's well-designed? Well, you're going to go and look at the data structure, and it's all there in the data dictionary. It's all defined. So you get hold of the data dictionary, use the utilities to access it, the ones that the DBA has, and list all of the record types. Read and analyze the descriptions of the records, the names of the records, verify the key of each record, and verify any requirements for uniqueness. So the key for the employee record might be the employee number, and that has to be unique. The employee name doesn't have to be unique. We could have 56 John Does all working for the organization, but they'll all have a unique employee number. Study the relationships and study the data sets. Read and analyze the description and names and pick up which of the relationships are one-to-many and which are many-to-many. Evaluate the strength of each relationship. Membership option specifications. You cannot have an order without it belonging to a customer. You can have a customer without them belonging to an order. You can have an employee who belongs to a department. You can have a department with no employees. You shouldn't be able to have an employee with no departments. You could have an item in multiple warehouses. You could have multiple items in multiple warehouses. So you could have many-to-many relationships. Look at those relationships and verify the consistency of the design with the business information needs. And that's where you'll pick up things like access, you can have many-to-many relationships defined where there should actually only be one-to-many. There's something wrong here with this design. It's also the documentation. That DDDS, remember, is a documentation tool, and we can use that to accept, record, and generate requirements and specifications, data documentation, metadata generation. From an audit perspective, you're looking for all of the definitions for your working papers. They're there. They're in the database environment. They're in the DDDS. You can use them for cross-referencing. You can use them for report generation. There are utilities, again, not audit tools, but utilities that the DBA has that can tell you which programs can access which pieces of data and what they can do to them. Which views of data, schemas, can see that piece of data. Which schemas can access that piece of data and update it. Which schemas can delete it. Which programs access using which schemas. And then ultimately, which users have access to which schemas through which programs. Is that appropriate based on the job requirements? So it's a tremendously powerful source of audit information. As I said, the advantages of that active data dictionary is it's accurate, it's on time, it's all there, and it's controlled for updates. So one of the key elements to the auditor is who can update that data dictionary. It should only be the DBA's deputy, and possibly in an emergency a third person kept under lock and key in a safe. You do not want every Tom, Dick and Harry with access to that and updatability soon. And believe me, the DBA will make sure that nobody but him or her can do that, because they're the one who's going to be held accountable if something goes wrong. It allows control through our metadata generation, and on that metadata there's a compiled date and time stamp which says that program was compiled and linked to this view of the database. Okay. I can have program execution lockout. I can say if the data dictionary does not know about that program, do not allow it to access this database. So if a programmer comes in and writes his own program, it can be blocked by the data dictionary. What it does mean is that you've concentrated the vulnerability in accessing that data dictionary directory system. So we need the DDDS to be able to protect itself. And we can do things like using status control. Once the DDDS has been flipped into production status, nobody can change it. It cannot happen. For any change to be made, it will have to be taken out of production status, and that's going to be the DBA and the DBA only. It's then going to be taken, a copy of it taken somewhere else to be modified, and the production status reinstated. It can now be modified, but it cannot run against live data unless it's back into production status. So it's up to the DBA to make sure that any changes that were made were authorized, were tested, are appropriate changes, and it's up to the DBA then to decide, will we replace our current production with that one? And we can protect it using password protection. From administration and coordination of functions, we can review and monitor activities as auditors. We can look at who is reviewing database design. It's not our job. We may do it in the course of an audit, but it's not our job normally. That's part of quality assurance of IT. Reviewing the system design, again, part of quality assurance for IT. Who is doing it? Show me the evidence. Show me the sign-off. Reviewing program design and coding, monitoring quality of data, monitoring performance. Monitoring quality of data, that's not up to IT, that's up to the user. Once again, as an auditor, I want to be sure that someone in the user area is monitoring that. And someone within the DBA function is monitoring the performance of the database management system as a whole to make sure that it is doing those things it's supposed to be doing and nothing else, and it's doing them in a controlled fashion. Segregation of duties can be built in, and we can look at the data dictionary to determine what concentration of risk exists. Now, it's an evolutionary development. You can fragment the function. You can have the distribution based on location, so people within the Washington branch can set up their own segregation of duties. These people, we've only got 3 employees here, so segregation of duties is not that critical. We've allowed everyone in this department to do everything because we've got good management oversight, supervisory oversight. Or we can have distribution based on the users, so we can enforce division of duties. And we're looking at data administration versus database administration. So in other words, a database administration is looking at how the database structures itself and is used. Data administration is using the systems development life cycle to define who can go where and do what, and what the deliverables will be. As far as the organizational issues are concerned, the roles in the database management environment which require segregation are typically database administration, systems development, programming, operations, end users, and internal audit. DBA should not be developing systems. Programmers should not be able to access the DBMS. End users should not be able to do anything except the functions that they're authorized to do. Internal audit should be able to look at everyone but do nothing. Okay? We do not want update access into any of these areas. We don't necessarily even want read access into some of these areas. We want sufficient access to make sure that the person who is responsible for controlling that area is in fact doing the job. Central administration of the schema and subschema. Again, it's the assignment of responsibilities for that data design, data administration, database administration, systems development, systems and programming, and we can integrate that into that whole SDLC that we talked about on Tuesday, and the roles matrix of who is allowed to go where and do what in the course of their normal job. Who should be, and then looking at the computer, who can. Once we've got it in and we think we've got it working, then we need to worry about changes. So we can look at control over changes within our DBMS. Remember, unlike changing one program, if you make changes at the database level, you could affect every single user in the organization, potentially. So we can classify our changes by the magnitude of effort. Is this a new system, the startup effort? Are we merging something new into existing components? Has legislation come in that means we have to modify existing components? Has something gone severely wrong and we're in emergency maintenance? And we can look at the component of the environment. Is this an application program that requires changing? In which case it could be a fix because something didn't work. It could be a new functionality that's been built in. Is it system software? Has a manufacturer brought out a new release of the software, which could have critical impact on the whole of your IT? Is it an enhancement? On data descriptions, are they reorganization? On data itself, do we need to clean things up? Do we need to scrub files? Something's got corrupted. It needs to be fixed. Who's going to do it? Who's going to monitor it? How is it being done? It all needs to be controlled, one way or the other. Controlling access. Again, we need to look at database environments from the impact on privacy and security. Access requirements among multiple users are a lot more difficult to control. And if you're going to have the same piece of data with multiple users in multiple locations, possibly in multiple countries, sharing that data, you can have major control concerns. Now, you can sort it out using that DDL, the Declarative Data Definition Language. It's actually DDL. It's a lot easier to be clear because you've got it in one place. It's not in every single program, and that makes it easier to audit. Again, we want to migrate the implementation of the controls out of application systems into the environment, the DBMS itself. Controlling completeness and accuracy. Well, once again, if you bring in a database system, the effect on the quality of the information provided gives you a concentration of risk because you're sharing data. If somebody gets something wrong, it's not their system that's screwing up, it's everybody's. And it means that there's an increased cost to fix things if things go wrong. The effect on user reliance and confidence can suffer, and you can get database erosion. Quality of database can suffer. You get cascading errors, migrating of controls for mitigating the concerns and controls involving completeness and accuracy. We're looking at them being generalized in the environment and implemented through the DBMS, the DDDS, etc., all of the components. And that brings us to our fourth polling question. And our fourth polling question is looking at segregation of duties. The roles that require segregation of duties in a database environment include the DBA in operations, internal audit in the DBA, end users in the DBA, or all of the above. Once again, please vote now. We've got another couple of seconds. We'll close the poll and share the results. And we have unanimity. All of the above. Am I making the questions easier? Are you getting more familiar with the jargon? One way or the other, let's move on. So with all of this in line, what's the impact on the auditor? Well, there's some nice things about auditing in a database type environment, and there's some not so nice things. Nice things from our perspective, consistency of data. You can look at the data dictionary and know that any program looking at the data is looking at it in this form. It can enhance the quality of the audit because we can get better accessibility. Instead of having to go and dig out documentation on system after system after system, and one's been written well and one's been written badly, and one's 3 years out of date and one's disappeared, it's all there. More accurate systems development process because you know exactly, and everyone knows exactly what the data looks like and how to access it. All systems are written the same way, so when we're auditing them, they're a lot easier to audit. We've got a consistent systems development process. Data resource management gets benefits through formalized disciplines, and we've migrated the controls into a central point where it's easy to audit. It doesn't necessarily mean they're correct. It means it's in one place and you can audit them in one place. Disadvantages. technology lust, the new technology or pioneer syndrome. I went into one site where the production system was written using IMS database. The costing system was written using IDMS. The manufacturing work in progress system was written using Datacom DB. Why? Because every time they changed management, he said, no, forget what we've done before. This is where we should be going. This is the latest technology. And now they have to maintain 3 different systems and the same data on 3 different systems. So now they have to build bridges and link all these things together. Absolute nightmare. Not only that, they have to pay the fees for the use of this software in 3 different types of software. Other disadvantages, implementation cost control. It can be a problem. Sometimes it's easier just to write a quick program rather than go through all of the rigmarole of development and etc. Access to DBMS managed data can be a problem. We can have too many people with access. You can have trade-offs with data integrity between accuracy and completeness, integrity of data, availability of data, and they're all pulling in different directions. And it can mean that the auditor needs to look at changing the scope or the timing of the audit. So what roles can the auditor fulfill? And when I say auditor, I'm talking about the auditor as an internal auditor and the auditor as an external consultant brought in to advise. We can be brought in to consult with the users on what their requirements are. When the system is going to be developed, what edit and validation rules should be in place? What should be done if something goes wrong? Do you reject the whole transaction? Do you accept part of it? Do you flag it to be reviewed? Who's going to do the review, etc.? Who is going to be responsible for the correctness? Now that's all user functions, but they may ask us to consult as independent arbiters because IT is telling them one thing and they don't know if they can believe them or not. We can consult with the DBA on the implementation plan. What tools will the DBA have available? What edit and validation that the user specified, element by element, how is it being implemented? Error response, we know what the user wanted, how is that being implemented? Does it match? We can ensure the existence of procedures for edit and validation maintenance. Are the edit and validation rules sufficient? If somebody wants to change something, on whose authority can they do it? Who will actually be physically doing it, making the change? Who is checking it? What are the procedures for adding new data elements to our database? As far as edit and validation, commonly encountered database management system supported edit and validation controls, uniqueness checking for key and non-key items. So only one person has that customer, or one company has that customer number. And it doesn't have to be a key item, it could be any item. This is unique. You can only have one of them. Structure and relationship checking, we talked about. Picture string and simple format checking. That's the one that says if we have a date, it must be month / day / 4 years. Unless it's a European one, in which case it's day / month / 4 years. Unless, of course, we're using Julian dates, in which case it's something, and so it goes on. We can build that in to the data dictionary so that when someone is entering data, it will not update the live data if the structure is wrong, the picture string is wrong, or the format checking is wrong. Now that's simple. I don't need to do it in every program. I can do it in one place and it will all happen. If we have a codicil database where we've got the chains and pointers, okay, our network type database, when I add a new person or a new record that's going into something which has a chain, will the person who's adding it, the user, have to define where they want it linked to? This is an order that will be linked to that customer, and this will be the last order in the chain, or will it be automatic? Because it can be set up either way. Using the DDDS from an audit perspective, in a passive DDDS environment, it's simply a tool for documentation with absolutely no guarantee that the application system bears any resemblance whatsoever to the contents of that DDDS. If it's active, then we know that edit and validation is being performed according to declaratively specified criteria. We can rely on it. The metadata generation provides that control, and it's not just for us. The DDDS provides the documentation used by the programmers, by the analysts, and by the users of the system. Just remember, as an auditor, you are a secondary user of every system. Other tools. Well, within our database management system, there's a component known as Database Input-Output Control, DBIOC, and that itself can be a tool for controls. Anything going in and going out of the database has to go through the DBIOC. And that's where we can put our completeness and accuracy controls. It's in one place, centrally maintainable, easy to administer from the DBA's perspective. From an audit perspective, from a management perspective, the security of that tool itself can be more easily verified. And if we're going to use data sampling as an audit technique, if we're going to create a SCARF, a system collection audit review file for later evaluation, we're wanting to gather data because log files are not contiguous. We're using before and after image logging. We don't have the whole chain. We want to keep certain records for the auditors. If you want to sample, that's where to put your sampling software, into the DBIOC, because everything goes through it. Other areas for audit to be involved. When the database is first set up, the new system has been created, and we now want to log our data into it. Controlling that initial database load is critical. Okay. Now, it's not up to the auditor, and funnily enough, it's not up to IT either. It's the user who is responsible. User responsible for providing that initial database content. User is responsible to spot check the database as it gets loaded to make sure it is what it's supposed to be. The auditor can come along and specify sufficient checking using statistical methods when appropriate. And again, remember I mentioned that you can load the database using utilities? Well, database load utilities can be augmented using exits. Now, another technical term. What is an exit? Well, an exit is a piece of coding that is inserted into a standard package. Okay. What does that mean? Well, what it means is that when you have a package such as a database management system, when the program runs, it says first do this, then do that, then do that, then do that, then do that. And you, the DBA, can select and say, when it comes to that stage, either do this, or do that, or do that. There are options for you to select. But there will come a point where you want to do something that isn't there. I want some coding that has not actually been built in. So what do I do now? And that's where the DBA can write or have written for them an extra piece of coding. And they can insert that into a specific spot. So when it says first do this, then do that, then do that, then when you get to here, check if there's anything extra that needs to be done. No. Okay, carry on. Or yes, Go off and do that, come back and carry on. So the DBA can have extra software written, putting controls into those user exits. I was in one client where we were looking at what was preventing certain users from running some of the DBA's software. And the head of IT said, no, it's not a problem. We have a user exit that covers that. And I said, no, you don't. Yes, we do. I said, well, I've checked the user exit and there's no software there. It must be there. It's always been there. I said, well, it's not there now. And when we looked at it, what had happened was they'd gone to a new version of the DBMS. And when they installed the new version, they forgot to install the software into the user exit. So they're sitting there saying, we've got this covered in our user exit, and there was nothing there. So again, from an audit perspective, if user exits are being used, I want to know who put the software in there, how is it being controlled, how is it tested, who authorized it, who can change it. If you're not using user exits, I want to know how is user exit use prevented, how is it blocked, who's blocking it, who's monitoring it. Restart and recovery software includes a whole pile of software that in itself can be lethal. Database patch utilities. Remember I mentioned to you about the auditor taking the monkey and putting it on their own back? It was a database patch utility allowing quick fixes to rectify errors if something's gone wrong, if a chain has been broken, to go straight into the data and go zap, fix it. Now, what that does is it allows the DBA to say either take the whole database and disable it so nothing can continue till this is fixed, or just this bit, disable that bit until it's fixed. Either now or as the current transaction is complete. But the problem with it is it's a very, very powerful utility, and it allows unrestricted browsing. It says on that slide it should be restricted to DBA staff. The problem was the auditors wanted to remove it from the DBA staff themselves. In any computer, someone has to have the keys to the kingdom. They have to be able to go and fix things when things go wrong. The trick is you don't want it to be everybody. Limited number of staff. You don't want it to be just one member of staff, because what do you do if that member is unavailable? So you give the access to those to the minimum number you need to have adequate control, with procedural control over the use of those utilities. And procedural controls means you get written approvals and records of when they're used, and somebody independently scrutinizes those logs, someone who knows what the logs mean. And that does not mean the auditor, someone within IT. Auditing the database itself, we can set our audit objective and assess the environment, look at the capabilities of the software, we can review the DBA function, we can review the designs, we'll take a look at each of these in turn. We can perform transaction impact analysis for relevant transactions, and we can do whatever substantive tests are appropriate. How do you assess the environment? Well, there's a checklist of environmental questions. Number one, do you have a formally established database administration function? Remember I mentioned that one where they had 3 different database management systems running? On one of them, they did not have a DBA who knew anything about that DBMS. The only person who knew anything about it was the user. So IT, if they wanted to make a change, had to go and ask the user, how do we do this? Is the administration activity project oriented or more formatted around the databases? Does senior management take an active role in formulating and monitoring database strategy? Or do they just stand back and leave it to someone else? Is there an active data dictionary? Are the control features effectively utilized? Are the databases implemented in conjunction with online technology? Are there corporate-wide data standards? Is there a formal SDLC? Now, those are easy questions to ask. The trick is, what do you do if the answer is wrong? We can also, at the application level, look at, do diverse users share databases of audit consequences that were not shared previously, not since the last audit? There have been changes. Are there different logical views of the same physical database? If there aren't, then everyone is looking at the whole thing every time, and your segregation of duties becomes a nightmare. Are databases planned, designed, and implemented around corporate information needs, or are they around the departmental needs of one particular department, in which case they become a nightmare to try and integrate into everything else? Can data from one user area be easily incorporated into other applications or not? And where you have users who have responsibilities, do they know what they are doing in their own sphere of influence? We can look at the software environment itself, and we can assess the capabilities of the software environment. Again, we look at it from two different perspectives: what is possible and what is implemented. Okay, so we look at the features and characteristics, and you'll get that from the vendor documentation, from education and training. I run training courses on IDMS databases, on IMS databases, on Oracle databases. But you don't have to go on an audit training. You can go on IBM's training. You can go on Oracle's training. You can go on the same kind of training that the DBA goes on, if that's where your primary focus as an IT auditor is going to be. But you're looking at what is possible. Then we look at what has been implemented, which has actually been made operational. So we'll talk to our DBA, and we'll take a look at the parameters for system generation to see what's actually been fired up within the system. Software assessment will look at what controls have been implemented within the DBMS, within the DDDS, within the DBDC, within the DBIOC. And the way we find that out, we look at the performance reports, which will be going typically to the DBA. The DBA function itself we can review. Look at the job description and the placement within the organization. Look at the involvement that the DBA has in the SDLC. Look at, are they using the DDDS? Look at the standard policies and procedures. You can evaluate the impression of others. I do not suggest you wander around asking the IT staff, do you think your DBA is any good? But you can easily pick it up when they say, oh, you want to know that? Speak to George. He's brilliant. He knows everything about that. Inside out, upside down, you name it. Go speak to him. That can give you a lot of confidence within your DBA function. Which brings us to our next polling question. And our next polling question is looking at software which is used to make quick fixes or rectify errors in the database, is commonly known as a recovery utility, a database zapper, database load utility, or the DBIOC. And I do realize that in some cases it depends on who you're speaking to. We still have a few to vote, so we'll leave it for another 5 seconds, speeding it up. Everyone voted who wishes to vote. We'll close it and share the results. Okay, generally speaking, they're known as database zappers. Okay. Now, some of the database zappers are in fact recovery utilities, but most of the recovery utilities are not necessarily database zappers. Okay, so let's take a look at cats. You're all familiar with cats? Small creatures, 4 legs, long tail, furry. This is a slightly different kind of cat. Computer-assisted audit tools and techniques in a database environment. 3 basic aspects of the database environment that you may wish to go and do substantive testing on. The system components themselves, the metadata, and the user data. Okay, the system components you don't normally get into doing audits of, but you can. How you would do it, it'd be a question of taking the stuff that came from the supplier, doing a load, generate, and run for the purpose of checking that everything that was supposed to be designed in is as it came from the manufacturer, and if there's any changes to it, there's documented reason why that's been changed. So we look at things like system component lockout, access controls, input error controls, input completeness controls. Testing the metadata, we would look at the schema, sub-schema comparisons to make sure there's consistency, and we can do that by comparing the actual internal control box to the storage structures. How you would do that, you go get hold of the technical reference manual for that particular DBMS, take a look at the data definitions of the schema and the sub-schema, have a look at how they would then appear in the internal control box, and then load the library, generate them from the DBMS control box, and compare them. What came in as to what is actually there right now. Again, you can look at that within the data dictionary comparison checks. You can do that for passive data dictionaries, but it's not so easy and it's not giving you as much reliable information, so most auditors don't bother with that one. Administrative checking, straightforward, same as you look at any admin within IT. You're looking at the system documentation and change control checks to verify completeness and accuracy of anything that's subject to maintenance. Looking at the status and version control reports, you get those using a utility out of the data dictionary, depending on which one you're dealing with. Verify the accuracy of current status and versions simply by looking at what the reports are saying versus what is supposed to be there. Looking at the audit trail of change control and going through it with the DBA and with the application personnel. As far as the user data is concerned, exactly the same as any other testing. You can use retrieval software tools, not necessarily audit software, but you may have retrieval software as part of the DBMS that the user's using, nothing to stop you using those. All kinds of sampling routines, and again we can use those on recovery logs. We can also do a derived data check. Okay, now derived data check would be using something like ACL or IDEA or Arbiters, in order to repeat what is supposed to be happening within the live system and verify that 2 + 2 = 4 on my system as well as in the computer. And again, you can do it using generalized audit software, or you can have it embedded into retrieval software if you wish. Testing the user data, we can do recovery log comparison checks. That's the after image. This is going to take time and it's going to take machine resources, so you need to get that agreed with IT before you start. Typically, you're going to take the current database. Now, you can only do this if it's not live. So if you have one that's only available during the online day, after the online day, you dump it off onto a tape or onto a disk somewhere else, load the previous database dump, apply all of the forward transaction journals, dump it out, reload the original one so you can go compare 1 to 2, they should be identical. If they're not, analyze discrepancies and make any adjustments appropriate. That's using the transaction logs. We can also do it using our before images. Before images exactly the same thing, but instead of saying take the old one and roll it forward, we're saying take the current one and roll it backwards. Once again, they should be identical. If not, you need to find out why. Now, you don't need to be doing this, but the DBA should be doing this on an ongoing basis, or I should say on a periodic basis, to make sure that the before and after images are in fact being correctly recorded. The audit tools available we've looked at: Active DDDS, testing application software, testing system software, retrievals. They're all there on the list. We've looked at them all. Our techniques: we can either test application software and databases to verify the effective operation of the controls. We can do test transactions, test generators, pseudo-live databases, parallel testing. We'll look at all of these in later webinars. Testing our systems and software and our system data, independent verification of where this thing came from. Is it a legitimate copy? Are you sure you're not using pirate software? And using all of the facilities. Audit tools: we can use modified audit software, we can develop special interfaces, or we can use the actual DBMS software itself with our audit inquiries embedded in it. We can do integrity checking software, which comes from the vendor, looking for integrity, looking for pointer integrity, index integrity. Depends on the database management system you're in, whether you've got them or whether you need them. And as I said earlier, you can use the DBIOC for audit purposes, putting your audit tests into exits using user-written software modules, any way you want. And that brings us, you'll be glad to know, to our final polling question. In our polling question, the recovery before and after logs are an integral part and function of the DBMS, not reflective of the actual history of the impact of transactions, do not meet the need or criteria for an audit trail, or are simple sequential data files. It's a slightly trick question, so I've been sneaky. I'll close the poll. And share the results. And we have most people going for A, with a split on B, C, and D. The answer is that it is A, perhaps. It may be implemented as an integral and integrated function. It may or may not be reflective of the actual history, depending on how much squashing out is being done. They may or may not meet the criteria for an audit trail, depending on how much squashing is being done. At the end of the day, they are a simple sequential file. I told you it was a sneaky one. Okay, let me hide that and take us to our final screens. Number one, are there any questions? Don't be shy. And once again, if you come up with any questions afterwards, you can always email them to Jim or to myself, and if we can't answer them immediately, we'll try and get back to you. We can perhaps bring them up on the next webinar, because coming up next is IT Basic Audit, Use of CATs. So now we're getting into the nitty-gritty of how you can use CATs, what you use them for, and what kind of CATs are there. Other than that, thank you for coming.
Thank you, Richard. That's great information, and we look forward to everybody coming back and joining us again next week for Audit Use of CATs and continuing the series on the basic use of IT audit. And also following that will be the advanced IT audit 5 sessions. So please join us, and thanks again for your participation and your attention, and we look forward to welcoming you back next week. So have a good weekend and have a good rest of the day. Thanks. Bye.
Bye.